Welcome, everyone, to our session on how to build custom AI apps with the Einstein LLM Gateway. A quick reminder that Salesforce is a publicly traded company, and to please make your purchasing decisions on products and services that are currently generally available. Before we dive in, a huge thank you to all of you, our trailblazers, our developers, our admins in the community for being here today and taking the time. We really appreciate your support and hope you're able to gain a lot from this session. My name is Kevin Chi. I'm an associate product manager here on our Salesforce AI platform team, and I'm joined by Shreyas Dond, who's a Comms Cloud delivery lead in our CSG team. And together, the both of us will be teaching you today about how you can embed generative AI across any application or workflow leveraging our Einstein 1 platform. You might have seen some amazing capabilities in our keynote this morning, and for this session, we really want to do a deep dive on the how and really leveraging our Connect API to power these custom workflows. Today, Salesforce has a lot of out-of-the-box solutions to help you get up and running with generative AI extremely quickly. Shown on screen is a couple across our sales, service, marketing applications, and these can be turned on and enabled in just a couple of minutes. We highly recommend checking out these solutions first before you develop a custom application. But say you've looked at these solutions and you have a custom flow of work or a solution that isn't satisfied by these needs. How do we extend these solutions and make them your own? To do that, I want to first take a deep dive into learning how our generative AI solutions currently built on our platform. It all starts with a prompt. As a quick reminder, a prompt is just some instructions you send to an LLM, and you get a generated response. An example that a sales agent might use could be along the lines of, write an email introducing me, a sales agent, to a new lead. But if we took this email in its current form and this prompt, you'll see that the response we get is very vague and generic. It's filled with placeholders, and our sales agent wouldn't be able to use this response in its current form. They'd have to go in, replace each placeholder for every customer they're writing to, making this a very cumbersome and a lot of effort behind it, so it's not personalized and it's not efficient. Taking this, we introduced the concept of prompt templates, which allow prompts to be easily reused and grounded with the relevant data so that these responses can be more relevant and personalized. So as you see here on screen, highlighted in yellow, we're inserting merge fields into our prompt templates that reference CRM data, and at runtime, they'll get resolved and filled in with the data they're referencing, depending on the customer or data record you're writing to. For example, we call this process dynamic grounding. For example, if we were writing a sales agent, Leanne Tomlin, who works at Acme, and she's writing to Mr. Jeff Jones, who works at Big Five Corp, at runtime, this would be our grounded prompt, filling in the merge fields, and with all of that data, we see that we get a much richer email. It's more relevant, it calls out key information from both parties, and our sales agent, Leanne, would have to do minimal edits to then send this email. You just saw how dynamic grounding and more data can produce more relevant outputs. But with all this data, you might be wondering, how do you protect it and ensure it never gets exposed? What if you have data that's super sensitive, like social security numbers, credit cards, and so on? The great news here is that as developers, you don't actually have to worry about any of this, since it's automatically handled by our Einstein trust layer. Let me show you what I mean. Before any prompt template is executed on our platform, we go through a series of pre-processing steps and checks before it ever reaches a large language model. Let's take a look. Starting from the left, we have our prompt templates powering our applications. The first step, secure data retrieval. We ensure that any data we retrieve for dynamic grounding is respected by the access controls and user permissions of that org. Then dynamic grounding happens, but as you saw earlier, we don't only have to pull in merge fields from standard or custom fields. We can pull in data from Flow, Apex, semantic search, being connected to Data Cloud and MuleSoft, and more. The possibilities here are truly endless for the amount of data you can pull in from any source. Any sensitive data retrieved through that process used for dynamic grounding is then masked through our data masking step so that we ensure an LLM never sees this data. Lastly, we add some pre and post instructions for prompt defense to prevent hallucinations and ensure our outputs are relevant and safe. The LLM gateway on the right side here is our abstraction layer for interacting with LLMs. They can be Salesforce hosted, or they can be externally hosted. But what the LLM gateway does is it handles all the authentication, the API schemas, to allow you to easily just be able to call a standard API and get a response and know that all your data is protected, even on our models behind an API, which are enforced through our zero data retention, ensuring that any data isn't stored or trained in external sources. The LLM gateway will then get us a response, and on the way back, our trust layer is still at play. We first detect toxicity to ensure that you have safe outputs. Then we demask any data that was masked in the ingestion process. And finally, we store all of this into an audit trail for users to go back and look at what has happened, including feedback on the generation. Thumbs up, thumbs down, did a response produce the expected output? So you can reference this and use for manual fine-tuning and adjustments later on. Zooming out a bit, let's see how this fits into our broader AI architecture stack. At the very top layer, we have our applications, and we also have our Einstein Copilot Studio, which I'm sure you all have heard a lot today. It's our low-code and no-code builders that allow the customization for these applications. And at the very bottom, we have our data and infrastructure layers that are powering this stack. What you just saw was kind of the middle layer, our Einstein trust layer and the model agility, which is abstracted away from you as developers, so you can focus on calling the APIs and focus on building great custom applications. To top it all off, this isn't a new architecture stack. It's built on our very same unified metadata framework, allowing you to unlock and connect your app from any application. A great tool that was built on this trusted AI architecture is our very own prompt builder. I'm sure you've seen this a lot already throughout the conference, but our prompt builder is essentially our tool that allows you to create trusted prompt templates that are grounded in data with really simple tools, and it is officially GA. We're not going to do a deep dive of the prompt builder in this session, but what we want to know is through prompt builder, you now have access to prompt templates, and now how do you embed those into your applications? How do you invoke them and tie them into whatever flow of work you need? That brings us to our Connect API. Let me show you how this works. You're probably all familiar with our pro-code and low-code offerings, and our Connect API is the way that it's actually the entrance layer to interacting with our prompt templates and our trust layer and gateway. So if you're coming from a pro-code application like Apex, LWC, or REST, you can invoke the generate messages from prompt template method, which lies in our Einstein LLM namespace. And if you're invoking it through low-code or no-code applications like Flow, we also have an invocable action that you can call directly. Regardless of which method you take, you'll send the prompt response, call the API, and you'll get a response back, all abstracted through the trust layer and the gateway that we touched on earlier. You can use those responses to then power your applications and surface the information in the relevant flow of work. Now, let's see this all in action with a real-world custom use case. To do that, I'd love to introduce you all to Samantha. She's a sales agent at Dreamhouse Realty, which is a real estate property company that helps clients find their dream homes. Dreamhouse Realty uses a custom Salesforce application, and Samantha wants to be able to embed generative AI to help improve her everyday work. What are some of those tasks? Well, for one, Samantha wants to be able to streamline her email follow-up process. Currently, she has to do this manually. She's on the phone with her clients, and it takes a lot of time to be able to perform her tasks and ensure they're high quality. Also, she's getting a lot of data from clients visiting properties, leaving reviews on these properties. She wants to be able to quickly summarize and condense this information down for her to know which properties are doing better than others. Last but not least, classification. Not only does Samantha want to know how her properties are doing, but also how her clients are doing. Customer satisfaction, customer health. She wants a way to quickly boil down all the reviews and engagement points that she's getting to understand how she's doing as a customer rep. Now, I'll hand it off to Shreyas, who will show you these use cases in a live working demo.
Perfect. Thank you, Kevin. So how is everyone doing? Great. So thanks, Kevin, for going over the Einstein Trust Layer and the Einstein 1 platform and the overall trusted AI architecture. Now, as developers and architects, what are we most concerned about? How do we leverage all of this in our existing standard applications as well as custom applications? So we are going to go back to Samantha. So Samantha is a sales representative. She uses a custom application at Dreamhouse Realty. One of the tasks she currently does is she talks to clients, helps them shortlist properties based on their search criteria. So let's look at how we can embed generative AI and help her generate a follow-up email that is personalized to the client and fits as part of her workflow. So let's dive in. So for this, we have used the Dreamhouse LWC application, which is available to everyone. We have added some certain extensions to this application. So as Samantha, when I'm talking to a client, I'm talking to Brad Holmes. No, this is Brad. So as Samantha is talking to him, she filters the properties based on his criteria. So he's looking for a 3-bedroom, 3-washroom home in Boston area. So she has filtered the results. As you can see, as part of this demo, we have added some instructions at the top. So Samantha goes ahead and shortlists some of the properties that Brad has highlighted. So now, in order to get started with generative AI, she goes and clicks the Send Listings button. This is going to open a custom workflow, which we have developed in LWC. She selects Brad as a contact. She goes next. She looks at the properties, verifies their description, asking price, and their parameters like beds and baths. Then she validates the addresses and Brad's address and just has some conversation with him to ensure that these are the properties he would like to go forward with. Then she hits next. When she hits next, we are invoking a prompt template. So let's take a look at this prompt template. So this is our prompt template that is being invoked in the backend. As part of this prompt template, we see that we are grounding the data with Samantha's username and Brad's username, as well as we are adding the 3 properties that we selected and their parameters. In addition to that, we have instructions. So we are passing it clear instructions on providing an email that is concise, provides a new subject line that increases the open rate, and also we are adding some CSS description to make sure that our generated email is good to look at and ensures that it has a click-through rate. Now you'll notice, as part of this grounding, we have an Apex class being invoked. So let's take a look at this Apex class. So this Apex class it has an invocable method called getPrompt. It is tied to the prompt template we just looked at. So it can only be invoked from that prompt template. As part of this Apex class, we are looking at the inputs. Based on the inputs, we are getting similar properties using an existing function. We are adding those properties to our output instruction as part of the prompt, and then we are returning the prompt. You will also notice that it has a strong request and response format that should follow the same request and response format that we are enforcing as part of our prompt template. Okay. Now, let's take a look at how we would invoke this prompt template that we were discussing from Apex. So this is the class that we would use to invoke the prompt template. As you see, we are using the Connect API, and we are using the Einstein LLM workspace, and some classes that support the Einstein LLM workspace. So First, we are generating the prompt inputs. We are adding some additional configuration parameters. So we only want to send Brad emails that are suitable and that are not risky. So we want to keep them in a defined format, but have some level of creativity to them. We are building the input map, which is adding the contact and the 3 properties we selected. And then we are calling the prompt template using the Einstein LLM generate messages from prompt template function. Then we are consuming that, and then we are passing it back to our LWC. So now let's take a look at our email. So this is the email that was generated. As you can see, it has a nice subject line. It has descriptions on the properties based on their parameters. And at the end, it has a nice message saying thank you for their business, and we look forward to helping them with their next property acquisition. So now Samantha can just click the send email button if she's good with whatever content was generated, and then she's good. So going back to our slide, we just provided Samantha the ability as part of our custom workflow to embed generative AI to generate a personalized email for Brad. Now, let's see what happens when Brad visits a property and then provides a feedback. So going back to our org, let's go to a property. So as part of our properties, we have a related list, which is the property feedback. This property feedback comes from Salesforce or can come from external systems. Now, we'll go back to the details of the property, and we'll notice we have this section, AI-generated feedback summary. This AI-generated feedback summary, we have 4 fields: the average rating, the sentiment based on the property feedback, a general summary of the property feedback based on all the feedback that was gathered, and actionable recommendations that we can provide to brokers and sellers to increase the traffic on the property. So let's see how this AI-generated feedback was created. So again, it starts with a prompt template. So this is our prompt template that's doing the bulk of the operation. So this prompt template is according to the perspective of a data scientist. So this is a key. We can really target what sort of inputs we want by giving it precise instructions and then perspective to get meaningful responses. So we are grounding the prompt template with a related list, which is the property feedback related list. So here we are noticing that we not only can ground the prompt template with CRM data that's directly inputted, but also we can ground prompt templates with related data to the record that we are passing it. Here, we are adding additional instructions to the prompt template to be more specific on their sentiment analysis. So we are providing it some examples for doing examples of positive reviews, some examples of negative reviews, and some examples of neutral reviews. So we are kind of tuning the model directly in our prompt template. And at the end, we are mandating that we get a defined JSON format as part of the response so that we can leverage it in our code automations. So let's look at our code automation that is utilizing this prompt template. Okay, so I will go back quickly. I'll open the setup. Okay. So this is our flow that is we are leveraging for generating that AI-generated sentiment and recommendations. So let's take a quick look at that. Give it a second to pull up. OK, cool. So as you can see, this is a record-triggered flow. So this is being triggered from a property feedback once it's updated or created. We are getting the property details as part of the first action of the flow. But we have this special component called prompt action. Let's take a quick look at the component. So this component, all it does, it invokes the prompt template and passes it input. Based on that input, we are getting the response back, and then we are parsing that response and using it to update our property record, which we see in our generated summary. So going back to our scenario. So now we just saw Samantha, how she can leverage, how we embedded Gen AI to give her meaningful insight on her property feedback, as well as give her recommendations that she can have a conversation with her sellers and brokers, and to increase the traffic on the property. Now, let's, Brad being our customer, he has visited some of the properties. He has provided feedback. He has also had interactions within Salesforce, not only with Samantha, but with other brokers. So he has a volume of data that has been accumulated that provides a good summary of all the interactions he had. So let's take a look how we can leverage that data to provide a satisfaction score for Brad, and how that satisfaction score can not only be used in Salesforce, but can be also used outside Salesforce by external systems. So going back to our demo, as you can see, this is our contact, Brad Holmes. And we have a simple LWC, which is showing a health score and the reasoning for the health score. Let's take a look how this health score was generated. Again, all of this starts with a prompt template. So this is our prompt template, Dream House Contact Health Score Summary. As part of this prompt template, we are using the perspective of account executive. And we have passed it clear instructions to provide a high-level overview of the client's interactions, and then using it to provide a satisfaction rating. You will see, as part of this prompt template, that we are grounding it with a flow. So let's take a look at this flow, what it's doing. Quickly going back, opening the flow. Give it a couple of seconds. Sorry, there it is. Sorry, I should have done this before, but a live demo. Okay. Hopefully it pulls up. OK, so there is our flow. So one thing you'll notice as part of this flow, you'll notice it's a special kind of flow. So this flow is a template-triggered prompt flow. If you see, we are also referencing that this template-triggered prompt flow can only be used with the Dreamhouse Contact Health Score Summary template. As part of this flow, we are getting data that is related to our prompt from the prompt inputs. So we are getting the contact, and there are some special components that are being used in this flow, which are adding the prompt instructions back to our prompt template. So let's take a look at one of these components. Yeah, so this is our prompt instructions component. As part of this component, we can leverage data that we have fetched as part of the flow to provide a structured context data back to the prompt template. So we are just passing the contact name, email, and phone. Also, as part of this flow, we are going through all the events for the contact, the task for the contact, and then doing something similar, passing the relevant fields from our interaction records back to the prompt template. Also, we are going through all the cases and the case details, comment details, and case feed details, and passing all of that back to our prompt template. So let's go back to our prompt template. The prompt template then leverages the data that we have passed, and we have given it specific instructions to generate a client health score, which is a satisfaction rating from 1 to 10, and we have mandated a defined JSON format as an output. Now, let's take a look at how we can invoke this prompt template from outside Salesforce. So we will demonstrate this using Postman. So in order to invoke a template using the prompt template using Postman, we are just leveraging a Connect API REST endpoint. The REST API endpoint is Einstein prompt templates, and we pass it the Dreamhouse Health Score Summary as our prompt template name, and then we are calling the generations endpoint with a specific input. As part of this demo, we are passing it a simple input, which is our contact, and some additional parameters, such as the application name, so that we can track and audit the call and then debug it further. As part of the response of this prompt template, you will notice we get a simple text back with a generated JSON that can be leveraged by an external application, such as a brokerage, CRM, or any other application within your landscape. And you get a safety health score representation, which can be leveraged by these external applications as well as internal applications to put thresholds on what sort of prompts we want to display to our end users. Okay, let's go back to our slide. So now we saw how we are leveraging Gen AI to generate a health score for the client based on all the interaction data that is accumulated in the system, and not only leveraging it within Salesforce, but also providing the ability for external applications to invoke and get real-time generations from our prompt templates for our clients. Okay, so now let's take a look at the prompt template data model. So this is key for the developers and the architects out there on how this fits into your build pipelines and how we can leverage it to build your prompt templates from your sandbox to your developer org to your production org. So this is the data model for a prompt template. And the main item in this data model is the Gen AI prompt template. So this is the container for your prompt template. It has the prompt template versions. So all of your prompt template versions are included in your Gen AI prompt template container file. Then it has input parameters, which are the parameters you are passing it to the prompt template. It also has data providers, which are the Apex, related list, and flow grounding that we are providing the prompt template. So let's take a quick look at a prompt template in VS Code. So this is an existing prompt template. As you can see, Gen AI prompt template, it has the current active version. It has all the inputs and the prompt instructions, the inputs that we are passing to the prompt template, the data providers, so in this case, it's Apex. And at the end, we have additional versions of the prompt template, so we can always revert back and control how we are leveraging the prompt templates to serve our clients. Okay. And all of this metadata can be used using the metadata API and can be leveraged as part of your current build pipelines to develop your code, deploy your code, and get it to production. Okay. So going back, let's take a look at the demo and what we learned throughout the demo. So the key takeaways here for our pro code section, we leveraged prompt templates in LWC via Apex. Then we also saw how we can invoke prompt templates through REST API from external applications. So they can leverage the same functionality that we have developed for our internal applications, as well as get the advantages of the Einstein trust layer and the guardrails that it provides. We also learned how to deploy prompt templates as part of your metadata for using your sandboxes to production, using the same build pipelines and same tools that you currently use. On the low-code side, we looked at how we can leverage prompt templates and ground them with existing CRM data, such as object and related data to the objects. Then we looked at how we can trigger prompt templates via flow, and how we can ground prompt templates with flows. So one key main takeaway, as Jordi would say, when some developer would come to you and say, let me just send a prompt template directly to LLM. So we can just say, why not use a prompt template and use the benefits of the Einstein trust layer? And now I'll pass it back to Kevin.
Thank you, Shreyas, for that amazing demo. And if you want to see all the code that was shown in our repository, please scan this QR code. We're going to leave it up here for a solid minute for folks to get all the valuable information. There's also links to other resources regarding our Prompt Template Connect API, as well as our Einstein Trust Layer. With that being said, we want to give a huge round of thank you to you all once again for coming out, and hopefully you were able to learn a lot about how to invoke prompt templates, embed them in your custom workflows, and what you don't have to worry about in the trust layer and all of the abstraction that we provide as a platform to allow you to build your custom apps.